In this tutorial, I'd like to talk to you about light reactions. This probably looks a little familiar to you. It's reminiscent of the electron transport chain that we talked about in the last chapter on cellular respiration. So let's take a look. As you can see here, we've got the light coming in, and this is hitting the first photosystem, which is photosystem 2. Remember in the photosystem tutorial I told you that the photosystems are named based on when they were discovered, not by the order in which they are in the pathway. So you'll see here that the light hits photosystem 2, and if you remember, I told you that that light energy is converted into the energy to excite the electrons. So where did the electrons come from? Well, I'd like you to see here that the electrons for the first photosystem came from water coming in and splitting. And when water splits, as you can see, it splits into electrons that will go into the photosystem 2, into hydrogens that will be accumulating inside the thylakoid membrane, and oxygen, which will be given off as a waste product of photosynthesis. So the 2 electrons that are in this first photosystem are being excited, and they go to this electron acceptor, and you'll notice that the electrons move through each electron acceptor in the electron transport chain. Just like on the electron transport chain in cellular respiration, those little releases of energy are what is giving energy to pump hydrogen ions across the membrane, this being, of course, the thylakoid membrane. Well, if you remember from the last chapter, it's pumped across the membrane because it needs to be pumped because it's going from, as you can see, a low concentration to a high concentration inside the thylakoid. So it's coming from the stroma. So let me write this out here. The stroma into the thylakoid membrane where it's building up. We're setting up this concentration gradient so that we can use these hydrogen ions again, much like we did in the electron transport chain. So if we get back to the electron transport chain, we see that at the end of this electron transport chain is another photosystem. And this photosystem is also absorbing light, and this is photosystem 1. So let me write that. I'm kind of making a mess here, but this is photosystem 1. And it's taking the electron that came along the electron transport chain, and it's exciting it, just like the first photosystem did. And so when photosystem 1 is done and gives it to this electron acceptor here, instead of going to another electron train, or electron transport chain, I should say, it's going to take the electrons and give it to NADP+, and when it gives that and a hydrogen to NAD+, it becomes NADPH. And you should notice now with the 2 little circles up here, those are representing the 2 electrons that it picked up. So you've probably guessed by now that NADPH is a new kind of electron carrier, similar to the electron carriers NADH and FADH2. And what that's going to do, as you can see here, it's going to go to our second step, the Calvin cycle. It's bringing those electrons, which is some energy, to the Calvin cycle. We're not quite done with the light reaction because just like in the electron transport chain ATP synthase in cellular respiration, we've got all these hydrogens building up, and as you know, the natural action of diffusion means that things want to go from a high concentration to a low concentration. So in this case, the hydrogen ions or protons want to go from inside the thylakoid to the stroma. And when they do, the energy that they are releasing as they go through ATP synthase, there's our old friend from the cellular respiration, as they go through there, that's the energy that ADP and P need to bond to make ATP. As you know, ATP is a molecule of energy, so what are we going to do with that? It's not used for cell work like cellular respiration was. It's going to be used in the Calvin cycle, which we'll talk about on our next tutorial.